All right, we now have the finding the needle in the haystack. What could go wrong? It's going to be wonderful. Gustav, thank you for joining us, and another lightning round of insights, so buckle up. You want to use?
Yeah, I'll use that one. Thank you. All right. I'm actually not sure if it's good or bad luck for me that Rob held the presentation right in front of me, before me, because I'll actually talk about a few things he just mentioned very quickly. So I hope it doesn't get boring. If it does, we'll just skip that. We are going to talk about finding the needle in the haystack. We are going to talk about noise and how to get rid of it. Who am I to talk about that? I'm part of the Ketchum Media Intelligence Unit. That means it's our job to provide the data people make decisions on later on. And as part of that team, it's my job to reimagine processes. That means I take projects that were long over by the time I joined Ketchum, and I try to reimagine them using newer technologies, using machine learning, using AI, using tools that might not be explored well enough so we can just give it to a client and say, here, that's that. But to try to see, okay, what can we experiment with? What can we do using machine learning and artificial intelligence? So what am I going to talk about today? I brought 3 things that I find really interesting that have gotten much better in the past years, and I think have gotten good enough so to actually take a big look at it if we are trying to cancel out noise. The first thing I want to talk about is text classification. Rob just mentioned a few of those techniques, which I really like, but I'm going to go more in depth. I'm going to talk about named entity recognition. He also showed that on that one slide containing Honda, just showing how you can extract with context what people are talking about. And then in the end, I'm going to talk about what a random forest has to do with all of that. All right. So the use case I was presented with, like I said, has been finished, delivered to the customer by the time I got my hands on it. And it's the following. A big car company approached us and said, hey, we are going to deliver new models. They're going to be different than anything we've done before. And we would like to know, what do people like about them? What don't people like about them? And how are they received in the public? I think that's something a lot of people can relate to, is what that might entail. And the thing was, we didn't have any training data. We didn't have anything to validate that on. We couldn't just train a machine learning algorithm and say, hey, we're done with this. This is good data. The other thing, we had the requirement that it was 6 different languages that we were supposed to track. And why is that problematic? Well, with all these approaches, we always talk about those models, but we are missing that languages differ quite extensively. And those small nuances might be really, really important for those kinds of analyses. So the first thing we wanted to approach was, what can we do in order to make this hurdle of different languages a bit smaller? We were just talking about queries and how difficult they can be, Boolean queries. That's a small part of a much bigger query that was used for that specific project. And I think we can all see that it's not just difficult, it's also very hard to digest. Now just imagine someone joins in the middle of that project, or the customer wants one more thing to track, and all of a sudden, this has to be adjusted. That's not an easy thing to do. How can AI help with that? We can move away from this kind of querying because we can finally use more natural language. Why is that a good thing? Well, because we sometimes miss things in these queries, or we add stuff that is irrelevant and only see it later on. So a good approach would be to actually explain it to someone, because what's written there on the right side, if someone else joins the team, if someone else is a new stakeholder, if a topic needs to be changed, you can have a look and you understand it in 3 seconds what they're talking about and what that is. I mean, we're not removing problems like that they are maybe stated in the wrong way, that the machine might not understand us. But it's a big step moving from those queries to actual natural language in those regards. And why is that cool? How can we do that? Because with those large language models, we can use a technique. I think most of you might be familiar with it, but I'm going to discuss it nevertheless because I think it's a very important basis. We have those models that get trained on billions of points of data. And then the easiest thing to do if you have very little data is to do something called fine-tuning. So instead of rewriting the whole model, we can take a small layer of the stuff we want to discuss and put it on top of that model. And that makes it so this very general model now moves to be our fine-tuned model to do a specific task. Why is that cool? Well, because we can give some examples of what we would like the answers to be that we're receiving. And it can be very, very few examples that you can use to have a big, big impact on how that is answered. For example, here, we take a few of those examples and we say, okay, that's the answer. So we're having a great product, 10 out of 10, that should be positive. It didn't work very well, it should be negative, so on. And we can use this kind of structure and move it into all different dimensions. A really good one to start with, for example, is relevance. We could just say, hey, instead of taking tens of millions of rows of training data, we take a few very well-chosen examples that show very well what kind of texts we want to keep in the data set, what might be relevant to analyze for us to actually get an opinion. And just write them down, give them the label, hey, this is really relevant to us, and push it into the system. So what I'm going to do is to actually show you some code. Now you might say, first of all, why is that? And second of all, I don't understand code. But that's fine. I want to show you how simple it can be to do these processes. Because for this specific task, I gave myself a challenge. I told myself I'm not going to use any of those tools, out-of-the-box tools that we get in order to do this analysis. But I'm trying to see how far can I get with very little computing resources, with very little training data, with all these challenges ahead of me. And that's one of the results. Those 20 lines of code are enough to get incredibly good results in tracking whether something is relevant or not. And I think that's crazy. At the top, I know it's very small, you can see a post that was very relevant to our data set. And I took that post, I took 10 more, I took 10 posts from the data set that were really irrelevant and classified them by hand. That took me 20 seconds. I pushed that into a very, very cool NLP library that we can use. That puts that on top of my large language model and says, hey, this is the input we're looking for. And with those 20 examples and that, I got working to a point where it returns irrelevant for stuff that is irrelevant and relevant for stuff that is not. And I think that's pretty crazy that we live in a world where 20 lines of code and 30 seconds of labeling data actually creates a system where we can do those kinds of things. Now you're asking, what does that have to do with me? And I'm saying more code is the answer. In our specific case, it was just talked about Roberta. I used BERT, which is the model that came before that, because it has a multilingual component. That means with a few lines of code, you can do that for multiple languages at the same time. And yet again, by the way, precision for irrelevant, that's down here, not very good. So there should have been more training data for this specific case. Nevertheless, I wanted to show that with 20 more lines of code, that's already possible. And it's crazy that in this day and age, we can do this so efficiently with data sets. And sometimes that's a good thing, because sometimes that means if you don't have the resources, or if the project is so small scale that it doesn't make sense to use one of your big do-it-all products, then we can resort to those kinds of measurements to get a first view on what the data might look like. However, and now I actually want to convey a very important point. Natural language processing and neural networks have gotten to a point where those small linguistics nuances I talked about can be conveyed in different languages using translation. Models like DeepL are able to catch those small things that are really important for the message someone is trying to convey and put it into a different language. We've had really, really good experiences with taking a multilingual data set and actually putting it in a single language. Why is that? Well, because, for example, for German, it's relatively easy to find a model that works well with that. For Bulgarian, it's not that easy. I checked that out today. I went to all the different websites and tried to see if there's good language models for the Bulgarian language. It's very hard. And I think it's crazy that we can all of a sudden leverage that just by translating the whole data set into a single language, for example English, for example German, where those models, they have a big variety. You can use them out of the box. Most of them are pretty good, actually. Okay, all right. Due to the time, we're going to skip that and move on to sentiment analysis. We just talked about that. And it's a metric that's very difficult, and I completely agree. And I think the only learning you should take from this is, yet again, it only takes 10 lines of code. 2, it's a very difficult thing that I could talk about for another hour, how to create models that are doing well on sentiment analysis. This is Waiter, this is out of the box, it's absolutely horrible. So if I can give you one advice, if you can get around sentiment, do it. Because the linguistics behind the understanding of how texts are conveyed and what emotion they convey is incredibly difficult. And I know some people like it because it seems like it's a good metric to show how people think about things. But in the end, it just takes so much time. But I put in the time. I put in the time to create things like this. So in the end, we were able to, with those 60 lines of code, create a working understanding of, for our use case, which car brands are talked about, in what sentiment, which models we talk about, how they look, and how people perceive them. And I think that's pretty crazy. And what do I want to convey with that? I want to make you take away that although this might not be production ready, it's still a good first step in order to leverage those newer machine learning models to get in first insight into what might be possible and which direction additional compilation might go to. All right. I asked you guys what your thinking was, what your experience was with all those models, and I think it's pretty great that that guy with the monocular is the biggest point, because it makes sense to be mindful that this is really, really new technology, and that there's a lot of things we still don't know about them. But I think overall it's very important that we explore them and that we have some fun with them and see, okay, where can they lead? Because this entry point has never been this easy. And while being cautious, we should also see that we explore those options correctly. Now, this was more a joke. This was more, I'm actually trying to see what people would respond to this. So if you want to discuss that with me, I'm very happy to do so. I would definitely be one of the first ones to be gone if AI is really as good as some people might make it seem. But overall, I think it's very important that we have to note that our jobs as analysts will change over time. I talked about linguistics a little bit, and I want to convey that again. While we're moving away from queries, while we're moving away from all those traditional things that we tried before, we're moving more into a territory where language gets more and more important. And I think us as communicators, we're good at language. And we should leverage that into the next thing. And I know there's 20,000 courses on prompt engineering. But if you've ever looked at one or two of those, then you see that a lot of that is based on, okay, what do I actually want? And do I have an understanding of what I'm actually trying to convey to that machine? And this kind of language with all those barriers with, I have to figure out in my head what I want to say, I have to move it into words, and then that words have to be understood by another party that is a machine who I don't know how it comes to the conclusion it comes to. That's very difficult. And I wanted to make sure that you understand that it takes training to create those kinds of systems. To in the very beginning, we have those prompts, and when I set up those kinds of systems with those examples, it sometimes takes me 1 or 2 hours to write those 2 sentences because they're so essential. They're so essential to conveying what we're trying to do. They're so essential for getting a data set that people can actually work with. And from a data engineering perspective, I think it is great that we are making this move, that I'm seeing that people are interested in that topic. And I want to say, be cautious of those tools because you never know what's behind them. You never know which model it is. But do some experimentation and try to make the most out of this because I think it's a pretty great time for AI. Thank you.
Everybody who's virtual, thank you so much. I think this was great to be able to break that down, and I think this is like the nerd love language, right? Of really being able to understand what people are saying to you and be like, this is how we solve that problem. You all do a lot of, just build on the earlier session about the building and the buying. What does that expertise on your team look like, and how do you keep them upskilled to be able to leverage these things so that they're able to only take an hour or 2 to write those first 2 sentences to get the outputs that you need? What does that training look like for the team?
It's very hard to answer that because I'm also still searching for those tools that make it possible to have all of this, because we're moving away from that point of data engineering is just writing code to we need a deeper understanding of the actual topics we engineer to. And the more we move into that new position, there's also people that just need different strengths. We have people on our team that are much better than me in writing queries, and I still don't understand how they do it. But those same people might not be as good as defining those texts. And people that have worked with text a lot, but don't have any experience in coding at all, might be very good at capturing the essence of what we're actually looking for.
I think that's so important because, there's good and then there's great. And then there's combining that hybrid approach of everything. And I know Mary Elizabeth is on our board, and it'll take a very strategic, thoughtful way of approaching that. And it's wonderful to watch and to see that evolution. Thank you so much, Gustav. Gustav's first time on the Amex stage for us. Please help me thank him again. Wonderful. We appreciate you.